Hello class, welcome to Algebra Concepts Lesson 3-4, which is all about the intercepts of graphs. By the end of this lesson, you should be able to identify intercepts of functions. So let's talk about some vocab. First of all, what is an intercept? An intercept is the point where a graph crosses the x-axis or the y-axis. So they're known as the x-intercept if it crosses the x-axis, and the y-intercept if it crosses the y-intercept. So if we look at this very first example here, with the orange, we have the x-intercept is the x-coordinate of a point where the graph crosses the x-axis. So if you look at this graph, this really curvy graph, you can see that we have 3 different x-intercepts. And the way that you write an x-intercept is you always write like the value of the x, comma, 0. And the reason you write it like that is because the x value, you're listing the coordinate for where it crosses. So here, that would be a -4 and then 0. If I asked you where that is on the coordinate plane, you'd say -4, 0. Because I went left 4 and I didn't go up and down at all. So it's just -4, 0. This one, it's not right on -2, but it'd be written what, like -2.25 comma 0, and this one looks like maybe like 0.25 comma 0. But the point is, x-intercepts you write as the number comma 0. And then the y-intercept is where it crosses the y-axis. So if we look at this, you can see that this graph, while it has 3 x-intercepts, only crosses the y-axis once, and it crosses at -3. So the y-intercepts you write as the 0, comma, the value of y. So this one would be 0, comma, -3. And it's 0 first because I didn't go left and right, but it's -3 because I went down 3. So 0, -3. All right, so that's x-intercept, y-intercept. All right, then we have the kind of last big idea for today's lesson is how to determine where a function is positive and where it is negative. So if you look at this function here, a function is positive where the graph lies above the x-axis. So for this graph, that's this curve right here, and then this line right here. So all of that red, that is our positive part of the function. And then over here, it's negative when it's below the x-axis. So you can see the part that goes down like that, and then the part that comes down like this. So that red, again, is the negative. And the way that you write where things are positive and negative is you use inequalities, like x is less than this, or x is greater than this. And we'll look at some concrete examples of that. Okay, so we've talked about the vocab. Let's start applying it to the examples. All right, example 1, intercepts of the graph of a linear function. Use the graph to estimate the x and y intercepts of the function and describe where the function is positive and negative. Okay, pretty straightforward. So let's start by listing our x-intercept. So x-intercept, I know it's going to be a number, comma, 0. And it's where it crosses the x-axis. So that would be this point right here. That's my x-intercept. And that's at the point 1, 2, 3, 0. Then let's talk about the y-axis. That's where you have 0, comma, and then wherever it crosses the y-axis. Sorry, we're talking about the y-intercept. I think I said y-axis. Talking about the y-intercept, it crosses the y-axis at 1, 2, 3, 4, 5, 6. So I do 0, comma, 6. Then I'm looking for where is this graph positive? Okay, so it's positive when it's above the x-axis. So that's all of these points up here. This is all above the x-axis. So the way that you write that is you say x is, and then if we look at that, our x value is 3, and if we go this way, where the graph is, our x numbers are getting smaller. So x is less than 3. Then our negative part would be going from here down. So now it would be x is, okay, if we're going to the right, that means that we're getting bigger than 3, right? So x is bigger or greater than 3. And that's how you would write your x-intercept, y-intercept, your positive function, and your negative, or the positive portion, the positive range, and the negative range of your function. Okay? So we're going to split this up, okay? There are going to be 4 different questions. The video is going to pause 4 times for you. You're going to start by just writing the x-intercept. So where is the x-intercept on this graph? Good luck. All right. Hopefully you said the x-intercept is at -2, 0. You put it right there. Okay, so now the next thing that you're going to look at is where is the y-intercept. Go ahead and take a second and look for that. Good luck. All right, hopefully you said the y-intercept, the graph crosses the y-axis at 0, 4. Okay, now you're going to type the range for the positive. So you're going to use those less than or greater than symbols. Where is this graph? Where is this line positive? Good luck. Okay, for the positive range, hopefully you said x is greater than -2 because it's above the x-axis on all of the numbers that are bigger than -2 for the x-axis. All right, and the last part is where is this graph negative? Good luck. Okay, and hopefully for the negative portion, you said x is less than -2 because our negative portion are all of our x values that are less than -2. If you have questions about that, please be sure to ask for some help. I am happy to help you. And let's move on to the next example, which is pretty much doing the same thing, but this time we have a curve in our line. Okay, so our x-intercept, you can see, hey, it crosses here and it crosses here. That means I have 2 x-intercepts. So my first one, I'm just going to list from left to right. So -4, 0, and 1, 2, 3, 0. So those are my 2 x-intercepts. My y-intercept is still, where does it cross the y-axis? So here it's 0, -12. Again, I just have one y-intercept. I don't have more than one. And now this is where things start to get a little interesting, a little more complicated. We're talking about where is this graph positive? So you can see it's positive right here and right here. But notice those 2 sections don't touch each other, right? So we're going to have 2 different things. We would say these numbers right here, x is getting, our x value is getting smaller, right? Because we're going to the left. So we'd say x is less than -4. And if we look over here, these numbers are getting bigger, right? X is greater than 3. Okay, so both of those are true. It's positive at both of those parts. Then let's check out the negative situation. Negative is where it's below the x-axis, which is this kind of the u portion of it. And if we look at that, we have the connected part, like this, the negative portion is one solid line. And when that happens, what you can do is list your 2 values. Okay, they usually match your x-intercepts. You put your x in between, and then you go like that. So x is greater than -4, right? It's bigger than -4. And x is less than 3. So I say x is less than 3. And that's all I have to do. All right, now I want you to look at this graph. And I want you to figure out which of these answers is correct. Is it A, B, C, or D? You're looking for the x-intercept, the y-intercept, the when it's positive and when it's negative. Good luck. All right, for this problem, I'm going to just kind of walk you through it. So letter A, it has one x-intercept at -2, 0, which, yeah, that's an x-intercept, but I see I have another x-intercept, so I know that it can't be this answer because there's only one x-intercept listed. Same with letter C, it only has one x-intercept listed. Then I look for what is my y-intercept. It's at 0, -2, so 0, -2, 0, -2. Okay, both of those are still working. Now I have to figure out when is it positive and when is it negative. So it's positive between -2 and -1. So I'm looking for bigger than -2 and less than -1. So if I look at this, positive when x is greater than -2 and less than -1. So that's correct. If I look down here, positive when x is less than -2, that's not true. So that means that my answer is letter B. Okay, if you have any questions about that, please be sure to ask for some help. I'm happy to help you. Let's move on to our next example, though. Okay, so we're finding the intercepts from a graph. I'm going to quickly just make this graph a little smaller so it's easier to see by a little bit, at least. Looking for this tool. So anyways, the graph shows the height of a ball for each second x that it is airborne. Use the graph to estimate the x and y intercepts of the function, where the function is positive and negative, and the intercept, and what the meanings of the intercepts are. Okay, so let's start with the x-intercept. The x-intercept would be way over here, which is 9, 0. Oops. 9, 0. So 9, 0. The y-intercept, where it crosses the y-axis, is 0, 4. Okay, so what do those two things mean? What do those intercepts mean? So if I think about this, this is the height of the ball. This is how many seconds have passed. So the ball starts at a height of 4 feet. And then after 9 seconds, the ball hits the ground. Okay, does that make sense? So you can see the ball at 0 seconds, so the starting point is at 4 feet high. It goes up and it hits like 9 feet, and then it comes back down, and at 9 seconds, it is at 0 feet. So that would be where it impacts the ground. It hits the ground, okay? And then the last thing we need to do is talk about where the function is positive and where the function is negative. So this function is positive for this entire thing, right? It's above that x-axis for that entire thing. So we would say it is positive from 0 all the way to 9. And then for negative, you would just say it is never negative. Okay, so there will be some questions where you will say that it's either never positive or never negative. That's okay, that can happen. All right, question 3. I want you to go through this problem. So we have the graph shows the population Y of birds X years after they were brought to an endangered species park. So I want you to find the x-intercept, figure out what does it mean. I want you to find the y-intercept and figure out what does it mean. Good luck. Okay, for this problem, hopefully you said the x-intercept was 8, 0, which meant that the population of the birds was sadly 0 after 8 years had passed. And then the y-intercept was 0, 50, which represented that at the start, when the birds were brought to the park, there were 50 birds brought to the park. Okay, if you have questions about that, please be sure to ask for some help. I am happy to help you. Let's move on to our last example for today's lesson. Violet starts the semester with $150 in her student lunch account. Each day she spends $3.75 on lunch. The table shows the function relating the amount of money remaining in her lunch account to the number of days Violet has purchased lunch. Find the intercepts. Okay, so I think you guys have probably picked up on how to identify intercepts with a graph. So let's look for, what do we need for a table? Well, if you see this, you're looking for zeros, right? So here, x is 0, y has a number. Down here, x has a number, y is 0. So which of those is x, which of those is y? Well, remember your x-intercept always has a number. So this would be 40, 0. And then your y-intercept is always where the x is 0 and the y has a value. Okay? So then we want to determine, like, what does this mean? What do those intercepts mean? Well, if we think about it in the context of the problem, Violet began with $150, right? That's what this says. After 0 days, she has $150. So she started with $150 and was able to purchase 40 meals with that money. Right? Because then down here it shows, like, okay, $0 left when we hit 40 meals. So that's what that what those intercepts mean. And this is how you tell whether you or where your intercepts are. You look for the zeros. Okay? All right, I want you to solve this one on your own. Grayson is creating a 2-ounce giveaway bag from a larger box of candy. The table shows the function relating the weight of the candy remaining in the box, y, and the number of bags, x, Grayson has created. Okay, so I want you to find the x-intercept. I want you to find the y-intercept. And I want you to figure out, what does that mean? Maybe like write a sentence explaining what each of these mean. Good luck. All right, for this problem, hopefully the x-intercept you said was 40, 0, and the y-intercept was 0, 80. And then what those two things mean, it would mean that Grayson began with 80 ounces of candy. Okay, so 0 bags, 80 ounces of candy, and was able to fill 40 bags, because down here you can see 40 bags, 0 ounces of candy left. Okay, so you should have had something like that for your sentence, and then you for sure should have had those x and y intercepts. If you didn't get that, or if you have questions about anything else from this video, please be sure to ask for some help. I am happy to help you, and I hope you have a great day.